What else do we know? We've learned the cast rule. We know CAST. And we know that this is a sine function that we're dealing with, right? Sine function. Now, sine in quadrant 4, is it positive or negative? What do you guys think? The sine function, is it positive or negative in quadrant 4? Well, clearly, only cosine is positive in quadrant 4. So sine has to be negative. And that makes sense because this is negative 0.7. So everything checks out. But guess what? We can use this information to help us find the other answer. Since we know that sine has to be negative, which other quadrant is sine negative in? Is it quadrant 1 the sine is negative in? Is it quadrant 2 the sine is negative in? Or is it quadrant 3? And I want an answer to this. So where is sine negative? Is it negative in quadrant 1, quadrant 2, or quadrant 3? We already know it's negative in quadrant 4 because we already drew that. Perfect. So a few of you are getting this right. Good job for the 2 of you who are answering. Well, 3 of you. Thank you. And yes, quadrant 3 is where sine is negative. And that is where our second answer lies, in quadrant 3. I'm going to erase this one here because we don't need it anymore. So now we need to figure out the angle from here to here. One good thing about these triangles is that they're symmetrical, I guess you could say. But what I really mean to say is that they have the exact same related acute angle. So forget the symmetry. All you really care about is the fact that the angle inside is the same. All right, so this is also going to be 44.4 degrees. So this angle inside is 44.4 degrees. What is my angle in red going to be? My principal angle. And if you figure this out, it's going to be 180 plus 44.4 degrees. And that is 224.4 degrees. So our two answers are 315.6 and 224.4. And the good thing about this unit is you can actually check your answer always. You can just plug in sine of 315.6 degrees, check what number you get, plug in sine of 224.4 degrees, check what number you get, and these two numbers should be the same or relatively close. Why do I say relatively close? Because we're not writing in exact values, we're writing in decimal values. So whenever you write decimal values, you're always approximating, you're always guessing, you're always like getting an answer that's close, but not exact. So that's why the numbers may not exactly be 100% the same, but they will be very close. So please, I ask everyone to do this right now. Take a calculator. Tell me what sine of 315 is going to be. And then do sine of 224.4. And you can see that they are very similar, right? I got negative 0.699 for both. And those are our two answers. We're done. And you can see here, that is how exactly they did it. 315.6 to 24.4. You have your two terminal arms. So just like that, now we're going to be doing the exact same thing. Except for another example here, we have tan. So we always start off by looking at the equation and just moving your trig function over and taking the inverse of whatever that value is. What's inverse tan of 2.1? And if you are in degrees mode, you should get the correct value of 64.5 degrees. And that's the answer. That is one of the answers. One of the answers is 64.5 degrees. So you're getting almost half marks there. And we know that this value here is 64.5 degrees. We know that tan is positive in this quadrant, which makes sense because everything is positive in this quadrant. But now the question is, which other quadrant is tan positive in? Because we have to draw another terminal arm, but the answer has to be positive. So it can only be in one other quadrant. What other quadrant can tan be in? Which other quadrant is tan positive? In the chat, anyone? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Where will I draw this terminal arm? No one knows. That's fine. It is in quadrant 3. Quadrant 3. Why is it in quadrant 3? Because tan is positive in quadrant 3, and we're dealing with a positive answer here. Perfect. Thank you, Anya. So here we have the same related acute angle. So whatever angle is inside this triangle is also the same angle inside this triangle. So here we have 64.5 degrees. Sorry about that. Okay. So we now have to draw an angle from all the way here to here. And we know that this is 0, 90, 180, 270. We know this angle has to be between 180 and 270. And specifically, we know that this up to here is 180. And more beyond that is 64.5 beyond. So all you have to do is 180 plus 64.5 degrees. That's going to be 244.5 degrees. And if you do that in your calculator, if you check your answer, you do tan of 244.5, you'll get a number. And you do tan of 64.5, you'll get a number. And those numbers should be the same or very close to being the same. That's how you can check your answer to see if you did it right or wrong. So very simple stuff. Let us do example 2 now. All right, example 2 says this point lies on the terminal arm. Find the angle to the terminal arm, principal angle, and find the related acute angle. So the way we do this is first we draw our point. We know that this is x and this is y. So that means that x is -7 and y is 19, positive 19. So x being -7 is here. Let's say this is -7. And let's say this is 19. So the point is somewhere here. So our terminal arm looks something like that. We always draw our triangle to the x-axis. Now let's label our dimensions for this triangle. We know that the distance from here to here is 7. How do I know that? Well, I know that the origin is 0, and I know that this is -7. So if I have to go from here to here, the distance, the length is 7. I know the height is 19 because from here is 0 and up top is here is 19. So I know the height of this triangle is 19, the base is 7. What about the quote-unquote radius? What is that? And it's very simple. All you have to do, now the question isn't asking us to solve for this, but I'm going to do this anyways because you may get a question on your